in today's lecture, we're going to discuss the next part, which is related to chapter Introduction to Coordination Chemistry. So, in this chapter, we're going to discuss the remaining part, that is the various terms which are related to coordination chemistry. So, let us start the terms which are related to coordination chemistry. The first terms which is involved in coordination chemistry is coordination compound. As its name suggests, a coordination compound is a complex compound in which number of bonds formed by your central metal atom or ion it is greater than that of their usual valency consideration. So these definitions suggest that if you look at a complex K3Fe6, where we have Fe as a central metal atom and its electronic configuration is shown at the bottom. So why its valency is 3? Because after removal of 3 electrons, that means 1 electron from d orbital and 2 electron from s orbital, we get the electronic configuration of Fe as its outermost shell contains 5 electrons. That means this orbital becomes half-filled. So automatically half-filled orbital has certain stability. So valency of this metal is 3. So what we expect, Fe should not form bonds greater than that of 3. But in actual practice, it forms 6 bonds with 6 cyanide minus sign. So such a type of compound where number of bonds formed by a central metal atom it is greater than that of their usual valency consideration, that compound it is called coordination compound. So coordination compounds are of 3 types, generally complex cation, complex anion, and the last one it is neutral coordination compound. It can be sometimes a combination of cationic complex or anionic complex, so that the overall charge becomes 0. Right? So this is all about the first term, which is coordination compound. Let us discuss the second term, which is complex ion. A complex ion is a charge species formed when metal atom or ion is directly attached to a group of neutral molecule or ions, and these neutral molecules or ions are called as a ligand. So simply we can say that whatever formula it is enclosed into a square bracket, if it is possess either positive or negative charge, then that species it is called as a complex ion. Here we have hexacyanoferrite. The formula for the complex it is Fe6, and it is enclosed into a square bracket and it possesses +3 charge. So these species it is called as a complex ion. Let's move to the next point, which is related to coordination chemistry. It is the central atom. So how we can define central atom? It is the metal atom generally present in neutral coordination compound to which 2 or more neutral molecules are attached. So if you look at the simple formula NiCO4, here we get the idea that oxidation state of metal it is also 0, and the molecules which are attached to that central metal atom, these are also neutral molecules. So the metal atom present in neutral coordination compound it is called as a central atom. Right? So examples we have NiCO4 or FeCO5, where oxidation state of nickel as well as Fe both become 0 and carbon monoxides are a neutral ligand. So this is the definition of central atom. Then we are going to discuss the fourth point, which is related to coordination compound or coordination chemistry. It is the central ion. If we already discussed what is meant by complex ion. So generally the metal atom which is present in that complex ion it is called as a central ion. Or we can say that it is the metal ion in the complex to which 2 or more neutral molecules or anions are attached. Right? So look at the example: cobalt attached to 5 ammonium molecules and 1 fluorine molecules, and it possesses +2 charge. So whatever complex ion we have, in that case the metal atom which is present inside the square bracket represents the central ion, because in that case the charge on metal it is not becomes 0. Right? For certain cases, even if there are certain complexes where total charge on complex becomes 0, but still the charge on metal it is not 0, and that metal species it is called as a central ion. So just remember the things that even though we are discussing that the complex ion having charge it is called complex ion, and the metal atom it is present in between in the square bracket it is called central ion. Even though this definition is true, but there are certain complexes which do not have any charge on that square bracket, either positive or negative. Total charge on that square bracket will become 0. Still that metal atom it is present in in that square bracket possess a charge. That means oxidation state of that metal. If it is non-zero, then that metal atom in that complex it is called as a central ion. So this is a simple definition for central ion. Then next very important definition which is related to coordination compound, it is a ligand. So what is meant by ligand? Ligand is any species, or we can say that any atom, ions or molecules which is capable of donating a pair of electrons to the central metal atom or ion. That is called as a ligand. Or we can simply say that the species which is capable of donating a pair of electrons to the metal, these are called as a ligand. So in other terms, it is also called as a coordinating group. So these are also called as a Lewis bases, because what are the Lewis bases? These are the species which donate the electron pair to Lewis acid. And generally we know that the atom which accept the electron pair, these are called as an acceptor, whereas those atoms which donate the electron pair, these are called as a donor atoms or donor site. For example, we have ammonium molecules, cyanide molecules or fluorine molecules, where we have these ammonia, cyanide or fluorine minus. These are all species which is capable of donating a pair of electrons. So all of them are being considered as a ligand. So this is the important term which is related to coordination chemistry. Let's see the classification of these ligands. So it is based on number of donor atom which is present in them. Just look at the first classification where we have monodentate ligand. So if the ligand contains only one donor atom that is capable of forming one coordinate covalent bond with the central metal atom or ion, then that ligand it is called as a monodentate ligand. Or we can simply say that if a molecule or atom or ion or group of molecules which is capable of donating only one electron pair and forming one coordinate covalent bond with the metal atom, that is, these ligands are called as a monodentate ligands, or sometimes these are also called as a unidentate ligands, right? So what are the examples of monodentate ligand? All the halogens belongs to the monodentate ligand category. Fluorine, chlorine, bromine, iodine, these are belongs to the monodentate ligand. There are certain polyatomic species, polyatomic ions, for example ammonia, cyanide, or more than two atoms or heteronuclear diatomic molecules which possess either negative charge, positive charge or neutral molecule. These are also capable of donating only one electron pair and forming only one coordinate covalent bond. In other terms, we can say that if only one donor atom, that species it is called monodentate ligand. So the ligand can be negative ion, positive ion or neutral molecule. Next classification, our next type of ligand, it is a bridging ligand. It is a subtype of actually a monodentate ligand. If the unidentate or monodentate ligand simultaneously coordinate with two or more metal atoms, such a ligand under these circumstances called as a bridging ligand. You can simply say that if a single ligand which is capable of attaching to two metal atoms with the simultaneous use of its electron pair, in that case such a ligand it is called bridging ligand, and the complex which is formed by this it is called as a bridging complex, because this it is look like to be a bridging complex. Right? So another example we have this carbon monoxide, it is acting as a bridge between these two Fe atoms. It is also a monodentate ligand and it is simultaneously coordinating with two or more metal atoms. So it is also a type of bridging ligand, and the complex which is formed it is called as a bridge complex here, because C carbon monoxide it is acting as a bridge between these two Fe. This carbon monoxide it is also acting as a bridge between these two Fe. So this is called bridging complex, or the ligand which is involved it is called bridging ligand. So next we have polydentate or multidentate ligand. So a polydentate or multidentate ligand is the one which contains more than one donor atoms per molecules. That means the number of donor atoms are more than one. So depending upon number of donor atoms which ligand possess, they are classified as a bidentate ligand, tridentate ligand, tetradentate ligand, and so on. Bidentate ligand means they donate or they possess two donor atoms simultaneously donating two electron pairs. Similarly, we have tridentate ligand, which is called as a which possess three donor atoms. Tetradentate ligand, we have four donor atoms, and so on. So these are the various subtypes of polydentate ligands or multidentate ligand. So let us discuss the next point. It is the chelate or chelating ligand. What is meant by chelate? Chelate it is look like to be a a Krebs clause. Right? It is just look at the definition of chelating. It is a polydentate ligand if a polydentate ligand with two or more donor atoms coordinated by the simultaneous use of two or more electron pair to the same metal atom, then the ligand it is called as a chelating ligand. That means we have monodentate ligand with the two different donor atoms. With these two different donor atoms, they are donating their electron pair to same central metal atom. Then that complex it is called as a chelating complex, and the ligand which is acting as a polydentate ligand with the help of its two donor atom and two electron pairs simultaneously coordinated to same central metal atom, then that ligand is called chelating ligand, and the complex compound thus formed is known as a chelate. So this is an example of chelate where we have ethylene diamine as a monodentate ligand. These two nitrogen were acting as a mono. These two nitrogen atom acting as a two donor atom, and with this electron pair, they are simultaneously coordinating to the both these simultaneously coordinating with the two or more electron pair to the copper. So these look like a Krebs clause. That's why it is also called as a Krebs clause. Or these complex, it is called as a chelating complex, and the ligand which is involved in these are called as a chelating ligand. So this is all about the polydentate or multidentate ligand. Let us see the various examples of ligands. So examples of ligand where we have monodentate ligand, water and ammonia, these are acting as a monodentate ligand. We have bidentate ligand, ethylene diamine. It is a symmetrical bidentate ligand because if we cut this molecule across these axes, then we have two equal halves. We have oxalato, which is generated from oxalic acid. We have two oxygen as a donor atom. This is also symmetrical bidentate ligand. Then we have dimethyl glyoxymato. It is represented as a DMG. Oxalato is represented as a OX. Ethylene diamine is represented as a EN. So this is also a symmetrical bidentate ligand where we have two different donor atom. Two nitrogen is acting as a donor atom. It is bidentate ligand. We have tridentate ligand here. We have three nitrogen acting as a donor atom. Here we are replacing hydrogens with the ethylene diamine molecule, another molecule. Then we have this tridentate ligand or triethylene tetraamine, where we have four nitrogen acting as a donor atom, or four. That's why it is called as a tetradentate ligand. Then we have hexadentate ligand, ethylene diamine tetraacetate. It is represented as a EDTA, where we have four oxygen as a donor atom and two nitrogen as a donor atom. So these are the examples of ligand. Then we see the monodentate ligand. These are the examples of monodentate ligand. Cyanide, we have nitrite oxides, NO3 minus, nitrate, fluoride, chloride, oxide. All these are monodentate ligand. There are certain positive species and still they have positive charge capable of donate a one electron pair. This includes a nitrosine, nitrosilium, or hydrazinium. Actually, the formula for this hydrazinium, it is N2H5 plus. One of the hydrogen is get removed, so it possesses only plus charge rather than 5 plus. So there are certain neutral molecules, carbon monoxides, ammonia, water molecules, hydroxylamine, methylamine. All these are the examples of monodentate ligand and capable of donating only one electron pair. Why I am showing this example? Because these are very useful in calculating the oxidation state. What kind of charge we have to consider for these ions whenever they occur into a complex. So these are the monodentate ligands. And next we have bidentate ligands. There are certain ligands, dipyridine, 1,10-phenolphthalein, glycinato, acetylacetate. This is actually an unsymmetrical bidentate ligand, which is represented as a glycinato. The 1,10-phenolphthalein, it is also symmetrical bidentate ligand. 2,2-dipyridyl, it is also symmetrical bidentate ligand. Acetylacetonato, we have two oxygen acting as a donating ligand. So it is called as acetylacetonato or ACAC. Then we have dimethyl glyoxynato, which is represented as a DMG. As we already discussed, these two nitrogen, it is having two different donor atoms. Then we have oxalato. So these are the examples of bidentate ligands. Some of them are symmetrical bidentate, some of them are unsymmetrical bidentate. Right? So what we're going to discuss next on the last point related to the terms involved in coordination compounds, it is coordinate covalent bond. It is a very simple definition. A coordinate covalent bond is a covalent bond where two two shared electron pairs are contributed by only one of the two atoms linked together. So the atom contributing electron pair it is known as a donor atom, while the atom which accepts the electron it is called as a uh, acceptor atom. The electron donated by donor and the electron which is accepted by atom it is called acceptor. Generally, the coordinate covalent bond it is shown by drawing an arrow from donor to acceptor. Right. So generally ligands are donor and metals are electron acceptors. So ligands can donate electron pair. So arrow can be drawn from ligand to metal. So this is coordinate covalent bond or dative bond. Then we have coordination number. It is generally the number of ligands which are directly attached to your central metal atom or ion. It is known as coordination number. So we can simply say that the number of groups which are inside the square brackets which are attached to metal atoms, these represent the coordination number. But what we have to consider in that case is that whether it is monodentate, bidentate or tetradentate, we have to count the number of donor atoms which are directly coordinated to your central metal atom. And by these number of donor atoms which are attached to metal, we can easily predict the coordination number. So generally metal shows a coordination number as a 2, 3, 4 and 6. So lighter transition element exhibit coordination number 4 and 6. Lighter transition elements belongs to first row transition series and second row transition series, and they prefer coordination number 4 and 6 because their complexity is being stable in coordination number 4 and coordination number 6. Then heavier transition element atomic number greater than 70 or plus, rather than 70, 75, 76 or 78 something. These are the heavier transition element and exhibit coordination number greater than 6. So over 6. So it is not, we are not concentrating on the fact that lighter element is going to show only 4 or 6 oxidation. They might show a variety or variable coordination number depending upon the ligands which are going to attach to it. We can say that the metal atom shows a different coordination number in different complexes just because of different ligand that provides different kinds of stability to the complex. So this all decides the coordination number, or we can simply say that the number of groups or ligands which are directly attached to your central metal atom or ion is known as coordination number. So these are the various terms which are related to coordination chemistry or coordination compound. In next chapter we are going to discuss